For our lesson number 8, we have the truss analysis method of joints. A truss is an assembly of members such as beams connected by nuts that creates a rigid structure. A structure that consists of two force members only, where the members are organized so that the assemblage as a whole behaves as a single object. Here are the examples of trusses: the bowstring truss, the scissors truss, front truss, truss with monitor, traverse bent, howie or howie, then the front truss, another front truss, and the different kinds of trusses. The assumptions on truss analysis is all the joints are pins, the applied forces act at the joints, and lastly, each member of the truss is either in tension or compression. Tension is when you pull the member of the truss, and compression is when you push the member of the truss. We have here a problem number 1 that says determine the reaction of the supports and the forces at each members. Classify if the members is tension or compression. As you can see here, we have an example of a front truss with a forces of 50 kN pulling or pointing to the left, and a force of 30 kN pointing downwards. The measurement of each truss is, the base is 2m and the height is 3m. So we have to find the reaction of all members and supports, and the supports we must find the RAX and RAY. So we're gonna moment at point A. So our first force that we're gonna moment is the 50 kN. So moment to A counterclockwise, the distance is 3, so negative 50 times 3 plus our force 30 clockwise to A, and the distance is 2 plus 2 plus 2 is equals to 6 minus our RB. This is our RB. So the distance are 2 plus 2 plus 2 plus 2 plus 2 plus 2 is 12. So the answer is our RB is equals to 2.5 kilonewton. So our Fx is, since we only have 50 kN, so that's our only Fx. So our Fy, or summation of Fy, is the RB. Our RB is upward, so we have 2.5 minus 30. Our 30 is downward, pointing downward, so it is negative, plus our RAY is equals to, our RAY is 27.5 kilonewton. So next is joints. From joint A, we have the 50 kN pointing to the right, and our AB and our AC, and our AB is pointing downward, our AC is pointing to the left, and our RAY is 27.5. So the summation of Fy is equals to 0 is 27.5 minus AB times 3 over square root of 13. It is our slope, which is the 3 squared plus 2 squared is equals to square root of 13. It is the measurement of each triangle in the truss. So, our Fy is, or our AB is equals to 33.051 kN in compression since it is pushing our member. So, our summation of Fx is 50 minus our AB times our slope, which is 2 over square root of 13 minus AC. So, our AC is equals to, so for our joint B, we have 50 kN pointing to the left and our BD pointing to the right, and our 33.51 which is our AB, then BC pointing downward and BE pointing downward to the right. So our summation of F, so for our summation of Fy, we have the AB, our AB which is 33.51 times 3 over square root of 13 minus BE times 3 over square root of 13. That is equals to, our BE is 33.051 kN and tension because it is pulling our truss. So, for our summation of Fy, we have our Fx, we have the negative 50 plus BD plus our 33.051 which is our B, or our AB, that is our AB, times 2 over square root of 13 plus BE. Our B is also 33.051 times 2 over square root of 13. The answer is, our BD is 30.333 kilonewton and tension because it is pulling our truss. So at joint C, we have 31.667 which is our AC and it is pointing to the right, and our BC which is the missing pointing downwards, and another missing is CE pointing to the left. So our joint C, since BC is missing, it is equals to 0 because there is no forces pointing at that point. So our CE is 31.667 also, since it is equals to our AC. So it is compression since it is pushing the truss. So for our joint B, we have the 13.333. It is our BD, and DF pointing to the right is missing, and the DG pointing upward to the left is missing. Then this is the 27.50 is our RAY. So our summation of Fy, which is to find out what is DG, we have the RAY 27.50 plus DG times 3 over square root of 13 is equals to 0, which, and then answer is